Stainless steel in orthodontics. Introduction. Stainless steel is a major alloy used in dentistry today. Stainless steel was discovered by researchers of Britain and Germany in 1913, first introduced in orthodontics by Wilkinson in 1929. In 1930, Angle used it to make ligature wires. By 1937, the value of stainless steel as an orthodontic material had been confirmed. Steel is an alloy of iron and carbon, where carbon content is not more than 0.2%. Passivation. Chromium forms a thin, transparent and adherent layer of chromium oxide, which provides a barrier and prevents corrosion of the underlying alloy. Composition. Silicon, phosphorus, sulfur, manganese, tantalum, niobium, etc. in very small amounts. The rest is iron. Types of stainless steel. There are ferritic, austenitic and martensitic stainless steel. Ferritic stainless steel contains 11.5 to 27% chromium, 0% nickel and 0.2% carbon. Austenitic stainless steel contains 16 to 26% chromium, 7 to 22% nickel and 0.25% carbon. Martensitic contains 11.5 to 17% chromium, 0 to 25% nickel and 0.15 to 1.20% carbon. Functions of constituent metals. Chromium. A thin, transparent, tough, impervious oxide layer of chromium oxide forms on the surface of the alloy when subjected to room air. This is called passivating film effect. It increases hardness, tensile strength and proportional limit. Nickel increases strength, increases tarnish and corrosion resistance. Cobalt increases tarnish and corrosion resistance. Manganese acts as a scavenger for sulfur and also increases hardness during quenching. Silicon is a deoxidizer and scavenger. Titanium inhibits the precipitation of chromium carbide. Types of stainless steel. Ferritic stainless steel, which is a body-centered cubic structure. It is stable between room temperature and 912 degrees. Carbon has a low solubility in this structure, and the alloy cannot be hardened by heat treatment, hence little application in dentistry. Austenitic stainless steel. Austenitic stainless steel has got a face-centered cubic structure with an AISI classification of 302 and 304. It's the most corrosion resistant of all types of stainless steel and is formed between 912 to 1394 degrees. It is also called 18H stainless steel with 18% chromium, 8% nickel and 0.15% or 0.08% carbon. Austenite is preferable to ferritic because of greater ductility, ability to undergo mold cold working without fracture. It increased strength during cold working. It readily overcomes sensitization. When austenitic stainless steel is allowed to cool slowly to room temperature, it forms iron carbide and ferrite. The iron carbide compound is called cementite and the solid solution of ferrite along with cementite is called pearlite. Martensitic stainless steel, which has got a body-centered tetragonal structure with an AISI classification of 400. If austenite is cooled rapidly, that is quenched, it undergoes spontaneous transformation to a body-centered tetragonal. The lattice is highly distorted and strained, resulting in a hard, strong and brittle alloy. Martensite decomposes into ferrite and carbide. Decomposition is accelerated by appropriate heat treatment to reduce hardness, but this is counterbalanced by increased toughness. This process is known as tempering. Increased strength and hardness and hence used for surgical and cutting instruments. It has got least corrosion resistance. AISI classification of austenitic stainless steel. The American Iron and Steel Institute is an association of North American steel producers. Its development was in response to the need for a cooperative agency in the iron and steel industry for collecting and disseminating statistics and information, carrying on investigations, providing a forum for the discussion of problems, and advancing the interest of the industry. There are three classifications for austenitic stainless steel: 302, 304 and 316L. Type 302, which has got chromium of 17 to 19%, nickel 8 to 10% and 0.15% carbon. Type 304 with 18 to 20% chromium, 8 to 20% nickel and 0.08% carbon. And type 316L, where L stands for low carbon. There is 16 to 18% chromium, 10 to 14% nickel and 0.03% carbon, along with 2 to 3% molybdenum. Austenitic stainless steel is preferable to ferritic stainless steel because it has got greater ductility and ability to undergo more cold working without fracturing, substantial strengthening during cold working, and greater ease of welding, ability to overcome sensitization, comparative ease in forming. Annealing. The effects associated with cold working such as strain hardening, low ductility and distorted grains is reversed by simply heating the metal. This process is called annealing. The more severe the cold working, the more rapidly the effects can be reversed by annealing. Austenitic stainless steel has non-magnetic ferromagnetic qualities develop as a result of cold working during fabrication due to formation of ferrite and martensitic forms. This magnetism is eliminated by a full anneal. The temperature of this transformation is termed the Curie temperature, which is around 700 degrees Celsius. Sensitization or weld decay. Austenitic stainless steel loses its resistance to corrosion if it is heated between 400 to 900 degrees Celsius. Decrease in corrosion resistance is caused by the precipitation of chromium iron carbide at the grain boundaries. Stainless steel becomes susceptible to intergranular corrosion and partial disintegration of the weakened alloy may result. Stabilization. This is a process by which carbon is made unavailable for the sensitizing reaction. This is done at the time the alloy is manufactured by either keeping the carbon content exceptionally low or by adding other metals such as titanium that tie it up with different compounds. Cold working. Cold forming stainless steel is generally different to plain carbon steels, primarily because stainless steels are stronger, harder and more ductile, work harder and more rapidly, and must maintain their inherent corrosion resistance. When stainless steel is cold worked, carbide is precipitated along slip planes, so chromium is dispersed throughout rather than concentration at the boundaries, and there is more protection from corrosion. Stainless steel has got high resistance to corrosion, and why? The chromium oxide is most commonly used as it forms a passive layer over the surface of the steel, preventing oxygen from penetrating the alloy. Molybdenum is added to stabilize the chromium, and copper is present in low amounts, adding to the corrosion resistance. Characteristics of clinical relevance. Spring back, that is maximum elastic deflection, the extent to which the range recovers upon deactivation of an activated arch wire. A measure of how far a wire can deform without causing permanent deformation or exceeding the limits of the material. Higher the spring back, greater the working range and lesser are the requirements of frequent activations. Stainless steel has a spring back lesser than nickel titanium or beta titanium. Resilience, the capacity of a material to absorb energy when the material is elastically deformed. It is measured by the area under the stress strain curve. Stiffness, the amount of force required to produce a specific amount of deformation. Formability. High formability provides the ability to bend a wire into desired configurations such as loops, coils and stops without fracturing the wire. Biocompatibility. It includes resistance to corrosion and tissue tolerance to elements in the wire. Environmental stability. Maintenance of desirable properties of the wire for extended periods of time after manufacture. This ensures a predictable behavior of the wire when in use. Joinability. This is the ability to attach auxiliaries to orthodontic wires by welding or soldering. It provides an additional advantage when incorporating modifications to the appliance. Working range and flexibility. The distance a wire will bend elastically before permanent deformation occurs. Flexibility is a measure of the amount at which the wire can be strained without undergoing plastic deformation. Stress relaxation. When a wire has been deformed and held in a fixed position, the stress may diminish with time even though the total strain may remain constant. Friction. Space closure and canine retraction continuous arch wire technique involves a relative motion of bracket over wire. Excessive amount of wire friction may result in loss of anchorage or binding accompanied by little or no tooth movement. The preferred wire material for moving a tooth relative to the wire would be the one that produces the least amount of friction at the bracket wire interface. Hooke's law. Hooke's law states that the elastic stress is directly proportional to the elastic strain. The line marked is a graphic representation of how the material will behave if the above law is implemented. The object will elastically deform and when stress is removed, it goes back to its original shape. Soldering. It is a process of joining two metals by use of an intermediate alloy which has a lower melting point. Soldering temperature is 620 to 665 degrees Celsius. Ideally, silver solders are used. It's an alloy of silver, copper and zinc to which tin and indium are added to lower the fusion temperature and improve solderability. Soldering should be observed in shadow against a black background so the temperature can be judged by the color of the work. The color should not exceed dull red. The flux is applied and the heavier gauge is heated first. Flux should cover all the area and the metal should be allowed to flow around the joint. The work should be immediately quenched in water. The flux used for soldering stainless steel contains fluoride to dissolve the passivating film formed by the chromium. The solder does not wet the metal when such a film is present. Potassium fluoride is one of the active chemicals in this respect. Flux aids in removing the oxide coating so as to increase the flow, dissolves any surface impurities and reduces the melting point of the solder. Welding. Joining of two or more metal pieces directly under pressure without introduction of an intermediary or a filler material. Spot welding is used to join various components in orthodontics. A large current is allowed to pass through a limited area on the overlapping metals to be welded. The resistance of the material to the flow of current produces intense localized heating and fusion of metals. The welded area becomes susceptible to corrosion due to chromium carbide precipitation and loss of passivation. Increased weld area increases the strength. Advantages of stainless steel. It has got high stiffness, high yield strength, high resilience, good formability, good environmental stability, good joinability, adequate springiness, biocompatible, corrosion resistant and economical. Disadvantages. Lower springback than nitrile, higher modulus of elasticity, more frequent activations are required. Heating to temperatures between 400 to 900 degrees can cause release of nickel and chromium, thereby decreasing corrosion resistance. Biocompatibility of stainless steel constituents. Nickel hypersensitivity. Symptoms of toxicity, rash, allergy and lung disorders, ear infection and tinnitus. Nickel is one of the most common causes of allergic contact dermatitis and produces more allergic reactions than all other metals combined. Chromium toxicity, symptoms, depression and emotional disorders. Orthodontic applications. Orthodontic wires. 18-8 austenite type wires are commonly used. Then orthodontic bands, brackets and auxiliaries like lingual buttons, lingual cleats, ligature wires and also used for making removable appliances. Variations in orthodontic wires. Types are coaxial, where 5 wires are wrapped around a core wire, braided, that is 8-strand rectangular wire, and triple-stranded, which is 3 wires twisted together. Conclusion. Typically, stainless steel alloys are fabricated from 302 and 304 alloys. These remain popular due to the low cost, excellent formability and good mechanical properties. Chromium present in the alloy makes it well resistant to corrosion. Generally, austenitic stainless steel is preferred because of greater ductility and ability to undergo more cold work without breakage. Can be annealed and tempered. The springback of stainless steel is lesser than that of nickel titanium and beta titanium and therefore usage is comparatively less. Thank you.